Recording. Alright, here we go, guys. So today, finally, we're going to explore and we're going to discover the power rule. So that way, when we're trying to find derivatives of things that are in polynomial form or polynomial type, we can find the derivatives very quickly and then use that derivative to find different slopes of different tangent lines. Okay? So this, I guess, if you want to call it a shortcut, I guess you can say that it is, but it's really a rule, okay? But before we get into that, we got to be able to review a little bit about exponent rules. Because like Montserrat was saying, how do I do it when I have a rational exponent or when I have this other cases? So that's what we're going to practice, okay? Yeah? So before we get started, let's review a little bit about exponents. Do you guys remember the rules of exponents or the laws? Are you sure?
Most of them, yes.
Yeah, most of them. Okay, so we'll go over them really quickly. But before we do that, let's just write this down. So we're going to get a function that I'm going to give you, and I want you to rewrite it in what we call polynomial form or polynomial type. Okay? They might not be a polynomial, but they're going to be in that setup. Alright? So before we do that, let's review the laws of exponents. Okay? So what was the first one? When you multiply, you add the exponents, right? When you divide, subtract the exponents. Power to a power, multiply the powers, right? Zero exponent, the answer is 1. Negative exponents, send it to the bottom, or negative exponent on the bottom goes to the top. Very good. So remember those rules, because throughout today's lesson you're going to have to go back to them, okay? Alright, so if I gave you a problem that looked like this right now is kind of a rational form of a function. It's a rational, it's a fraction, right? So I need to rewrite this so that it looks like something to some power. So how could I rewrite it?
X to the negative 6.
X to the negative 2. Okay, that's what I want it to look like before I find the derivative, because that's going to make the application of the shortcut that much easier. Okay, is everybody okay on how I did that? I changed from where it was, so it was positive on the bottom and I moved it up, so the exponent becomes what? Negative. I also have to know how to go backwards, because at the end of the problem we don't want to leave it looking like this. We want to end up rewriting it back in the original form with the exponents positive. Okay? How about if I give you this one, the square root of x? What's that one going to be? X to the half. Oh, you're good. How did you know it was a half power? I told you last time? Oh, okay. Well, what if I did this? What if I make it the b root of x to the a power? What would that one be? X to the a over b. Why is the b on the bottom? Because it's a root, right? And the roots of a plant grow on the bottom of the plant, right? Unless we plant it upside down, right? Does the roots grow on top? No?
They would still get to the floor.
They'll still go down?
It's
What makes them go down?
Gravity.
Oh, gravity. I forgot
It's
about
not
that.
actually that.
I forgot about that. You're right, you're right. You have this imaginary force that's pulling us down.
Imaginary.
Well, it really isn't imaginary. But anyways.
Newton was full of it.
It's all a lie. It's
Who
like the
killed the
government brought us to
dinosaurs?
keep us
That's
from
what
flying
He
away.
was the one that killed it.
Alright, so the cube root of x squared, what would that one be?
Gravity doesn't exist and the earth is flat.
X to the
One of those is
2/3. Beautiful, okay? Alright, let's get nasty. Here we go. 1 over the cube root of x to the 4th.
Goodbye.
Oh,
Negative.
I got you.
Wait.
1 over.
No, wait, don't answer yet.
Fist pump, alright. Alright, so that would be what?
There you go.
X to the what? Negative 4 over 3. Oh, he's good, he's good. So he made it 4 over 3 down here, and then he sent it up to the top. Yeah? Are you guys mind blown?
Yeah.
I did 2 steps in 1.
Ooh.
Okay? We're getting better at this. How about this one? Okay, Vanessa, you ready? X to the 3/4 denominator. What would that be rewritten as? you're good. X to the negative 3 over 4. Okay? We also need to be able to eventually make it go back to this at the very end of the problem. Because I don't want you to leave it like this at the end. You have to convert it back. Okay? We have to convert it to an exponent at the beginning, and then at the very, very end, convert it back to a radical form. Okay? Because it'll be easier to figure out the answer when I plug in a number if it looks like this rather than this. Especially if I don't have a calculator. Okay? Alright, we're almost done with these examples and we can get into the good stuff. So negative 5 over 3x squared. What would that become?
X to the second times negative 5.
3x to the second?
To the negative second.
To the negative second?
And then you multiply.
Wait, what?
What's 3x squared? So this is like negative 5 over 9x squared?
Oh yeah.
Okay. So then what should we do now?
Negative 5.
Do I move the 9 also or just the x squared? Just the x squared?
Oh.
Ooh, so let's move this guy up. And we're going to look at him like this. Negative 5 over 9 times what? X to the negative 2. I'm not literally going to put him up there with the 5. I'm going to put it next to that fraction just to make it that much easier to work with. Okay? One more. Negative 12 radical x. What would that become? To be in polynomial form. To the half. Good job, Caitlin. Excellent. So negative 12x to the half. Why to the half?
Because it's
The 2 is on the root even though it's not there. So that's a 1, right? 1 over 2. Good? Alright, let's try this one. X divided by the cube root of x squared. Let's do it step by step. What does the bottom change into? X to the 2 over 3. Okay, and then we send them up. So now we have x times x to the negative 2 over 3. And what was the rule about multiplying? When you multiply, you add the exponents, right?
Wait, I didn't learn this one.
Okay, so how do we add them? We're adding 1 plus negative 2/3. What's 1 the same thing as? 3 over 3, right? So this is like 3 over 3 minus 2/3. That gives us x to the 1/3. Beautiful. Now I can work with this and find its derivative quickly. Are we okay? Did I lose you by making 1 3 over 3? We're okay? We're going to do that a lot, okay? So we got these skills down? We're okay? Alright, so we're going to use a lot of that in a little bit, but before we do that, okay, let's actually talk about one specific function, okay? So looking at this, it says, consider the function f of x equals 3. What does the graph of that function look like? So if I graph this, what would it look like? Okay, so she says a horizontal line. At what? At y equals 3. Right? Okay, so let's draw it. One, two, three, and you got my horizontal line. Yes? So it says, if a tangent line were drawn to this function at any x, what would the slope of the tangent line be? So if I draw a tangent line on it, what do I get? I get the same line, right? Okay, so what would the slope of all those tangent lines be? 0. Okay? So would it be safe to say that if I ever wanted the derivative of a function that was constant, that derivative would always be what? 0. Can we say that? Yes? Do we understand why we can say that?
Yes.
Like if I said y was equal to 5, what would you tell me y prime was? Y 0. Because this is a horizontal line. If I draw a tangent line on it, that line will be horizontal, will be on top of it. And the slope of that line will always be what? 0. Do you understand?
Yes.
Yes? Okay, so let's write that up. The slope of any tan line drawn to a constant function will always be what? 0. Do we know why? Yes. Okay? So let's do some extra examples. So if I said y equals 7, what would y prime be? 0. You're finding the derivative of 7, it's 0. What if I say s of t equals -3? What would s prime of t be? 0. Why? Because it's a constant. The derivative of a constant is always 0. The slope of a horizontal line is always 0. Understand? Got that? Yes? That's one of the first rules that you have to remember. Okay? The derivative of a constant will always be 0 because it's a slope of 0. It's a horizontal line. Good? Alright, here we go. Time for the good stuff. Right? So it says shown below are 6 different polynomial or polynomial type functions. Watch as I find the derivative of each and see if you can figure out the algorithm that I'm using for each function. Okay, so you're going to watch me get the derivatives of these guys right before your very eyes, instantaneously. And you're going to try to figure out what it is I'm doing to find it so quickly. So quickly that I don't have to use the definition of derivative anymore. Are we ready? I think some of you already kind of have an idea. And let's see if it actually works out on every single case. You ready? Here we go, let's do it. So my first derivative of this guy is going to be 6x minus 2. Boom, I'm done. I found the slope generator. The next one. Here we go. Negative 15x squared plus 4x minus 3. Done. Got my slope generator. Go for it. Use your definition of derivative. X plus h to the third plus 2 times x plus h squared minus 3 times x plus h. No?
Yes, I got it.
You got it? Let's try the next one. 0 minus 9x squared plus 24x to the third. Do we have an idea of what it is I'm doing?
Yes.
Yes? What is it that I'm doing?
The degree.
The degree, okay, the power,
I'm saying
times the number in the front. Okay, that gives me 6. Okay, that gives me 6 times the coefficient.
It's the degree times the coefficient again, which would be 1 and 2.
And then what happened? How come there's not a 2 here anymore?
Because you subtracted that
You
one.
dropped 1.
How much do I subtract?
One.
Just 1?
Yes.
You sure? 1 times 2? Negative 2, and take away 1, that becomes what?
0.
0, okay, and what about the derivative of this 3? Not give it?
Just 0.
Why is it just 0?
There's no like degree, there's no degree.
Because it's a what?
Constant.
Constant, oh, okay. Does it work here?
Yes.
3 times negative 5?
Negative 15.
Well, that's what I got. And then you take away 1,
drop
and we get 2?
1.
Yes.
Why did I put a 0 here?
Because it's a constant.
Oh, there's a constant, okay, cool. Alright, let's try a couple more, see if it really works. Try these here. What's this derivative going to be? Let's see what Mr. Science gives you. 2x to the negative 2 minus 6x to the negative 3. Ooh, is that what you got using your rule?
Yeah.
Yeah, we'll take it.
Yeah?
Yeah, because it's still one
It's the
less,
same
so you
rule as
still
yours.
subtract one, so you have -2.
Oh, that's how I got -2. So I subtract 1, so now I have -2?
Yeah,
Okay, cool.
because 1 minus 1.
1 minus 1 is 0? How come I didn't put 0? Oh, -1 minus 1. So that's -2, right?
Yeah.
Oh, okay, cool. Try the next one. What's that one gonna be? 4x to the what?
That's a great question.
-1/3 minus 8x to the negative. Why is it -1/3?
You minus one, like a total one.
Minus one.
Which is 3 over 3.
So
Which
it's
is
like
3 over
1/3.
3, so you're left with -1/3, right? Ooh, how cool. Okay, how about this last one? -1/2 times 6, that's what? 3? X to the negative what? -3 over 2, beautiful. Plus 3 over 2x
To the negative.
to the negative half. So now do you know how to do it? Good? Alright, so what is it that we figured out? Let's write down the rule that you discovered. So find out the power rule for